Hey guys, this is Devin here with Hillbilly Networks. I wanted to go over a quick video on the structure of a fiber and a fiber cable. But before I do that, I want to show you a picture of two different types of fiber that are pretty common. One would be a tight buffered tube fiber, and the other would be a loose buffer tube. A lot of times you'll see those in use, a loose buffer tube being outside and a tight buffer being inside. In this picture here, you can see what's called a tight buffer tube fiber, or several tight buffer tube fibers. As you can see, they're inside, and they're inside of a patch panel actually. That's a VFL attached, a visual fault locator that emits a laser light so you can visibly see it throughout the fiber. If there's any macro or micro bends. The reason I reference this is when I go on to talk about the fiber structure, I'm going to be mentioning a tight buffer tube, as you see here, as well as a loose buffer tube. And now you'll see in this picture here a loose buffer tube cable. And as you can see, it's outside. It has a much more rigid protective jacket on the outside that is not rated to be inside a facility due to the fact the type of smoke it would emit if it was burned would be toxic, and therefore is against fire codes. It's called a loose buffer tube because there's several buffer tubes loosely within the cable. They're loose in there so that if the cable bends, flexes, moves around, it keeps the buffer tubes from being pinched, bent, or damaged. They need that room to flex because that cable is going to be moving. Whether or not you're moving it, when it's on aerial poles, it's going to be moving and swinging back and forth. The poles will naturally move with the wind. Okay, so now that we've went over tight buffer tube and loose buffer tube, we'll start by looking at the picture on the left of the basic fiber structure. First off, you have a core. That's where the light travels down the fiber. The core is 5 to 9 microns in a single mode fiber. The cladding is wrapped around that, and that is 125 microns in a single mode fiber cable. And then you have the jacket, which in a loose buffer tube would be 250 microns. Oftentimes people are going to see that as a coating. It's usually color. There's a color code because those are so small you can't have any writing on them. So you'll see blue, orange, green, brown, slate, white, red, black, yellow, violet, rose, and aqua. Those are the 12 colors that you see in a fiber optic cable. That would be referred to as the coating, or in this case, they've referred to it as the jacket. That can be stripped away. The cladding, however, cannot. A lot of times you'll hear people talk about fiber and they'll say, I'm stripping away the cladding. Technically, you cannot strip away the cladding. That would be the coating, the color. The cladding itself, that 125 microns section, is actually there to keep light within the core when it's traveling down a fiber. Of course, that was the original design purpose. That was the intended purpose of it. However, more current research has actually found that 20% of the light traveling down the core actually escapes out into the cladding. It makes its way back into the core, in and out of the cladding, and it hits the transceiver on the other side, or the optics SFP. But again, that cladding's intended purpose was originally to keep the light traveling within the core. The way it does that is the cladding actually has a different index of refraction than the core, meaning that basically the glass is clearer. You would think the core would be the clearest, but the cladding itself is actually clearer. And having a different level of clarity between those two causes the light to focus within one or the other, and in this case, the core. Now, I just discussed a 250 micron and how that coating is what you're actually stripping away and not the cladding itself. Now on a 900 micron, the jacket would be a lot thicker. That one, I would almost say it's about the size of the tip of a pen. In most cases, when I've seen it, it's either been white or yellow. It itself is not color-coded, unless it's in a large inside plant cable. Usually when I deal with 900 microns, it's a jumper, which there's one fiber in it. The exception to that would be if you are splicing patch panels and you're splicing, say, 24, 36, 48, so on and so forth, you are going to have different colored fibers in that case. But if it's just a single patch cable, it's generally going to be yellow or white. The image on the right has a little bit more information in it, and it actually makes me think that the jacket in this image was intended to appear to be the actual jacket on the outside of the cable, meaning the cable I showed you earlier that was the outside plant cable, the black part of it. And if that is the case, then I would note that in the first picture, if that jacket is in fact the larger portion of the cable, which could be 3 millimeter, for example, if it's a jumper, then there's actually a coating outside of that cladding that's missing on that diagram, which I would actually say is the case. So pretend that there's another layer outside of that cladding called the coating, which is the part you're actually stripping away. So on the right side, you'll have the core, then you'll have the cladding, then you would have a coating, and then you would have a Kevlar, which is a yellow yarn-like material that helps protect the fiber, just like it says, Kevlar, bulletproof. A lot of times outside plant fiber cables are chewed on by squirrels, they're hit by shotgun pellets, struck by vehicles if it's on a riser pole, meaning if it's traveling down a pole to go underground, and many, many other things. One more thing I'll add on the Kevlar is that is actually contained in outside and inside rated cables. So the jumper I was referring to, if you strip away that 3 millimeter jacket, you'll actually see that yellow yarn inside of it. It's actually very annoying. It gets caught on everything. The wind, skin, dead skin on your hands, dry skin, it clings to everything in sight. Outside rated cables, they're even worse in some cases. If you've got a dry cable, that's awesome. That means it just has this little piece of string inside of each buffer tube that's supposed to absorb water and prevent the accumulation of moisture inside the buffer tube where the fibers are contained. Because you don't want water inside there, because whenever it freezes, it's going to shatter the fibers. But if it's not that dry kind, that means it's got gel inside of it, which stains your clothes. It sticks to freaking everything. It's difficult to get off. You can use alcohol to help get it off. There's a D-gel they make for that. Either way, it's very annoying. I prefer the dry cables. The only time I've found where that gel actually comes in handy is when you're setting out in the wind and you're trying to get that fiber to lay in the tray. If there's still some gel on it, it actually will, they'll kind of cling together and go inside the tray a little bit better. But you're technically supposed to get that off. So the last thing I'll cover on inside versus outside cables, because there's a million things you could cover on fiber and cables. There's so many different kinds. So many different kinds I haven't worked with. But the last thing I'll cover is the main differences between an inside and outside rated cable. The most obvious is outside is rated for outside use, meaning that it has a more rugged or more rigid jacket to protect it from the elements, whether it be from squirrels, which in that case you could have armored inside of it. We don't, because it's close to our neutral. I work for a power company, so obviously we don't want armored in that case. But that jacket is meant to help protect it from the elements. It also has that gel or that yarn that piece of string inside there in that buffer tube I was talking about to help absorb moisture and protect it from water if there were to be a tear cut in the jacket, or if a squirrel starts chewing on it or anything like that. But the other notable difference is because the outside cable has that PVC rigid material on the outer jacket, it is highly toxic if burned and is therefore not rated for indoor use. The NEC actually has a code that is supposed to prevent you from running it more than 50 foot inside of a facility. There are some exceptions to that. If you look into it, you'll see some verbiage in there about using conduit, but I would encourage you to read up on it if you're going to do that, because the type of conduit, it has a specified type, I believe it mentioned, and I haven't read the whole code on that. I would venture to assume it probably has to be fire stopped in the end. Otherwise, what's the point? Because fire could get up in the pipe and then you're still emitting that toxic smoke. But basically the easy way to resolve that is if you have an outside rated cable and you need to run it indoors, say 200 foot inside of a building, just convert to use a splice box to convert to an inside rated cable. So you just take your cable straight in, down the first wall or somewhere like that, put it in a splice box, splice it, put in a bulkhead connector, and then just convert to an inside rated jumper and run that across the facility. Honestly, the jumper is going to be easier to pull through conduit if you get the right kind than it would be to pull through this big thick cable, because more than likely you're either working with, probably if it's an outside plant, a flat or a round, thick round cable, and either one of them can be difficult to pull through the type of conduit, the size of conduit you would normally see in a building. If you've got a 2-inch conduit in a building, great, it's probably going to be a whole lot easier to pull, but most of the time inside buildings, the standard I see is 1-inch conduits, and it's not so fun to pull that cable through. But anyways, that about sums up what I plan to cover in the video. I could go on and on about fiber. There's so many different types of cables, fiber. There's multi-mode, single mode. Different countries have different types of cables. Different regions use different types of cable structure. There's sea cables, land cables, cables made for underground, cables made for aerial. There's multiple types of aerial. Hundreds of types that I've never worked with, very few that I have. We use all dielectric self-supporting for all of our fiber, other than the inside plant, of course. So that's what I'm used to working with. If you guys have any other questions or anything you'd like to add, feel free to leave them in the comments. Thanks.